Welcome. Thank you very much for listening to us and our presentation. My name is Miroslav, and I will talk about our work on introducing machine learning into critical care units. The goal of our work was to understand if we can create a machine learning setup to identify clinical events in specific kind of surgery. And on top of that, what we wanted to understand was to find a way how to collaborate with each other. And in this paper, we collected a number of experiences and recommendations that we would like you to take with you when you establish collaborations in cross-disciplinary teams, in particular teams that are related to hospitals and machine learning. When starting our collaboration, we understood that there is a big discrepancy between the two worlds of medicine and software engineering. On the medical side, there is a lot of questions when it comes to research related to how we conduct the medical profession about the risk, for example, in our case of upcoming cerebral ischemia, and how to treat patients, of course. Now, in software engineering, the questions have nothing to do with patients. The questions have to do with the technology that we use to solve the problems that the medical domain has. So our problems are usually about the types of algorithms we should use, how do we store the data, how do we construct the entire system, the entire data flow, and how good those data flows are, and how do we establish this as a practice in the clinical environment. Now, the goal of our project was essentially, in this case, to evaluate whether we can replicate a medical professional's understanding of a specific operation with machine learning. So we wanted to know if we can detect the different events, in particular a clamp-on event during a carotid surgery, which was simulating the procedure, or which was the procedure that simulated the lack of cerebral perfusion in the brain, which means basically the blood flow in the brain was stopped. Why is that important? Well, this is important because we would like to know in the end whether we can use machine learning to continuously monitor patients that are, for example, in a coma, and understand and detect those kind of events in the coma patients, so that we could, first of all, be able to detect those kind of events, ischemia or lack of cerebral blood flow, in people who are asleep. And we want to prepare for the next step, to do the same things, but in a much, much faster environment when it comes to thrombectomy, and look at the healthy patients as well. So in this particular paper, we created an end-to-end setup that started with the data collection at the operating room, labeling of the data and quality assurance. We used a specific equipment, which is called a Moberg monitor. You can see that on the figure here. That Moberg monitor is used to collect all the signals from one patient during the entire procedure, and also mark the events during the surgical procedure. Then we used the export of data to a specific program, and the manual labeling of the data by the physicians who was part of this particular operation and procedure, to identify those green periods that you can see in the figure, that are essentially data that is clean of noise and that can be used for our analysis later on. And then here comes a bit of my part when we start looking at the feature extraction, labeling, and visualization, and quality assurance. As you see here, I'm using TS&E diagrams, which are diagrams that show us how far away different type of vectors of features are from one another, and different colors over here show how different events are different from each other. That gives a bit of an understanding how good the machine learning algorithms could be in understanding those events. Now, in the machine learning, in the end, we also have this presentation and visualization. Of course, we use different types of machine learning. For example, random forest, support vector machines, or even decision trees. Now, sounds very simple. So what's the problem, essentially? Well, the biggest problem is the fact that we when we started collaborating, the common understanding of what we want to do was a bit of a challenge. So first of all, everyone talks about data, but what is really data? What do we mean by that? Is it the fact that we have a video recording from the OR? And turns out no. Data, in order to have good data, you have to work together for a long time. In our case, it took us about 2 years to come to the place where we can set up this data flow and have good results. Then the robust setup, for example, took us a few months to understand which events should be labeled. There's a lot of things that are happening during the operation, but not all of that is essentially needed. And in the beginning, we labeled everything, and it turns out that it's a bit too much. And then we have to understand who has to do it and when it has to be done, both online or offline. And finally, examples of reliable analysis, for instance, which signals are the most important ones. And also, when we see machine learning algorithm taking a decision or making a recommendation, which signal is used to make that recommendation? And does it make sense for the clinical professionals as well? So how do we address that? Well, when we started this collaboration, we essentially said that we would be working together physically. So we designed the study together, we kept a journal of all our activities, and I was part of the hospital environment. As you see here on this picture, this is part of my journal, which I was writing what do you expect to do during a specific day, or what actually happened, and then make my notes of that. Now this is a very, very small one, and usually my journal was about 2 or 3 pages long with different pictures and descriptions. We also made a list of our main findings for all of these days, but here you can see only the first few days. So if you look at the first day, we started to understand, or I wanted to understand in the first day, how to use that Moberg monitor equipment. I mean, how does it really work, what you can and cannot do. And then I basically realized, regardless of the features that the Moberg monitor has, I understood that the data pipeline has to have some manual intervention, otherwise it's not going to work. For example, labeling of data on pressing the buttons and so on. That also, first day also provided me with an understanding that I need to set up this collaboration together with my friends from the hospital and together with my colleagues in such a way that it actually works in the operating room. Because even if the surgical procedure, the carotid surgery, is not really a super fast and it doesn't require emergency procedures, it's pretty controlled, takes its time. Still, you cannot wait for people to make notes in the monitor for different events. So those kind of things helped me to understand what we actually need to do in the next step. So this journal and the summary of made findings was really, really good for us to discuss later on in the project. Now, some of the recommendations we would like to give you when you start working with those kind of collaborations are described in phases. So first phase is finding the right partners. Now, sounds of course very easy when you already have a partner, but finding the right partner is really an interesting story, because what you want to do is you want to get results for both domains. And in order to be able to do it efficiently, I think when we discussed that in our team, the most important part was to find the data that you can bootstrap your collaboration with. In our case, my colleague had some old data that I could work with and understand how it works, how to do this study. And of course, organize a brainstorming as what we can do together and what is interesting. Now, of course, once we do that, the important thing is to go home to your respective domain and start thinking about research questions. So if I'm going to do this study as a software engineer, what do I want to get out of that? So we came up with this way that you should prepare a list of questions, everyone involved in the study that you're interested in, and then discuss and make a plan of that. So group them together and say, for this particular study, we're going to address those questions, and we could do it like this and like that. That helps us a lot in understanding and making an impact for both domains. Now, once you do that, of course, you would like to do pilot studies. And pilot studies are very important because you have to understand the environment. So first of all, you have to understand the environment from the software engineering perspective, how the medicine really works. I mean, of course, I knew that it's not Grey's Anatomy kind of way of working, but I didn't realize how far away that is from Grey's Anatomy. That it's really, really professional, and a lot of things are done in a very good way and a very structured way, and there's a lot of procedures for already in place, of course. Now, my colleagues also understood how I analyzed the data. So when they looked at how I did that and how I made my analysis, data cleaning, they also understood what they could improve before that comes into place. And of course, we made a few mistakes in those pilot studies, so we had to redo certain things, but they were very, very useful for us to understand how the whole thing is going to work. And finally, data analysis is a very important part, because when we do have the pilot study, when I establish things, for example, one thing that we discussed that was very good was that we took one patient and we took one entire operation and went through that. We look at the feature important charts to understand the machine learning models, whether these signals that were collected from the patients were essentially good signals and needed signals for the models. And when we do the analysis of the confounding factors, we also understood that we have to provide summary charts that link the medical domain and software engineering domain. For example, we would like to know whether the entire surgery and procedure was actually good for everyone. So we went through the entire procedure for one patient, minute by minute, and understood what was going on. How was that visualized in the data that we collected? And we had all the professions with us, so both the anesthesiologists and also neurologists, neurosurgeons, and everyone who was involved in that, and specialists in almost every signal we were collecting. So the results that you see are like this. In this paper, we only present them from a few patients that we have. As you see, patient number 2, for instance, and 3, they have a lower accuracy, or even patient number 2 doesn't have any accuracy at all. And those simply because some signals, when we were collecting the data, were corrupted. So for example, EEG signal in the patient number 2 was corrupted by the ECG signal when during the procedure, one of the electrodes basically fell on the operating table and was collecting different kind of signals. And then it was unfortunately done in such a way that before certain events, this was not the case, and after certain events, that was the case. So if we try to train the machine learning model based on that, the model actually learned that mistake rather than what was happening in the operating room. So to summarize, I think that this collaboration is really a fantastic way of software engineers to learn how to work with data and how to work with other professions to build systems that actually make an impact. But I also think that this kind of collaboration requires a lot of effort and a lot of understanding for each other. Now, I'm extremely lucky that in our team, we not only have a lot of work, but we also have a huge amount of fun learning and understanding each other, looking at the diagrams and trying to make and remake analysis, and we do the analysis and add things and collect the data and set up the procedures. So all in all, this team has grown from 2 persons in the very beginning to almost 20 in the end of this study. And all of my colleagues that are co-authors of this paper are also part of this team and part of this research in both design, analysis, data collection, and interpretation and manuscript writing. So without further ado, thank you very much for listening, and I hope that you can enjoy reading the paper. Thank you.
Hello, everyone. We have
Hello, everyone.
We have Miroslav here, and we have a couple of questions in the chat. So let's see. First one comes from Grace. Question is, in your opinion, Miroslav, what is specifically different about multidisciplinary collaboration for software development when machine learning is involved?
So I think the understanding is very different. When it comes to normal software development, I think all the experts understand the complexity of putting the requirements right. But when it comes to the machine learning, the importance of setting up the infrastructure and be able to work together from the very beginning is different. you don't have that usually in a normal software development.
Thank you. And we have a follow-up question from Jane. Did your domain experts have an intuitive knowledge of which signals would be important?
Yes, they did, although it turned out to be wrong. I mean, for example, this NIRS signal, which is a near-infrared spectrography, which is supposed to be very, very troublesome instrument because it's basically a patch that you put on the forehead, and then it reads brain oxidation from up to 4 centimeters into the skull, so to say. And of course, a skull is much deeper than that. So we thought that it would be a signal that is not really worth very much. But it turned out that in this particular case, it was the most important signal that could be could in our case function as an oracle. So to some extent, yes. To some extent, no. We actually thought that the EEG signal would be the most robust one. And that intuition turned out to be completely wrong because it was the signal that was the most prone to disturbances.
Thank you. Then we have another question from Jane. Let's see. Presumably, the medical professionals already know exactly how to read the signals. Did your ultimate approach mimic the way they recognize and analyze signal events without the benefit of machine learning?
No, I mean, to some extent, maybe, but it wasn't really the goal, and it didn't really do that, so to say. So you could mimic that, of course, but what we tried to do is we tried to use some of those signals as an oracle to train to recognize disturbance or to recognize patterns in other signals to be able to minimize the cost and the number of signals that you have to collect from the patients, because that takes time. And of course, in our situation, that was possible because this operation was very slow pace, so there was no emergency. But in the operations that we work with right now, when we have the emergency situation, we don't really have that much time to set up all the equipment. So we have to use as few signals as possible in order to minimize the time that is required to set it up before the patient is actually undergoing a surgery.
Great, thank you. And last question from Ivica, at least for now in the chat. This is a system in which reliability and safety, for example, is of extreme importance. How do you treat the question of trustworthy?
So that was one of the issues that we tackled from the very beginning. I mean, before this particular study that's described in this paper, we did a number of different pilot studies where we used the same equipment on other type of patients, where we wanted to see how to establish this data analysis pipeline. And then ultimately, when we actually did start with the actual study, what we used was the random forest algorithm, where we could look at the feature importance chart to be able to see how the actual algorithm recognizes different events, and ultimately to also provide some sort of trustworthiness that we're not looking at random patterns, but we are looking at patterns that could be explained by the physicians and the anesthesiologists in the real time as well.
Great. Okay, we have 20 seconds. I guess we don't have time for another question. We will move to the discussion room, and you can have some more discussion with Miroslav if you have there some questions. Thank you for the presentation and for the questions in the chat.
Thank you very much. I hope you liked it. Thank you.